Despite having only about 1/14 of Japan's maritime area, South Korea still harvests over 4 million tons of seafood annually, securing its place among the world's high-tech fisheries powerhouses, with a total value reaching $8 billion USD. Few people know that South Korea's fishing industry once stood on the brink of resource depletion and a severe fishing ground crisis, facing pressure from massive Chinese fishing fleets while being constrained by limited fishing areas and declining marine resources. So how did South Korea turn the tide, not just surviving, but becoming a model of ocean industrialization? In today's video, let's join Agriculture Insight as we explore how South Koreans transformed their seas into a nationwide production system, gradually turning fisheries into a strategic pillar of food security over decades. Let's dive in. With an annual catch of over 300,000 tons, South Korea ranks among the top 3 mackerel-producing countries in the world, behind China and Japan. Beyond generating hundreds of millions of dollars in revenue, mackerel is closely tied to the harsh years following the Korean War, when it served as an affordable source of protein, helping sustain over 20 million Koreans amid severe food shortages. Today, this fish is not only a cultural symbol, featured in the fragrant grilled dish godeungyeogui on Korean dining tables, but also one of the key pillars of the nation's fisheries industry. From May to October, as warm monsoon winds sweep across the eastern waters of the Korean peninsula, the silver migration, the season of the nation's iconic mackerel, officially begins. Compared to the world's leading mackerel producers, South Korea is no less advanced in technology or fishing operations. Its modern fleets are equipped with multi-layer sonar, radar, and precise navigation systems. Instead of relying on experience alone, sonar has become an eye beneath the ocean, allowing fishermen to monitor the structure, density, and movement of fish schools in real time. Massive purse seine nets remain the optimal solution for harvesting large migratory mackerel schools. When the moment is right, with a single command, the net, spanning hundreds of meters, rapidly closes, enclosing millions of fish at once. Immediately after, high-capacity vacuum pumps draw the fish directly from the net onto the vessel through enclosed pipes, reducing handling time and minimizing damage to preserve freshness. And in less than 30 minutes, over 200 tons of fish can disappear from the ocean, a massive yield that once required an entire fishing village weeks at sea to achieve. Despite using similar technologies and fishing methods, South Korea deliberately pursues a balance between volume and value, rather than maximizing output like China, or pushing quality to extremes like Japan. This approach allows South Korea to both sustain its fish stocks and shape a stable, long-term mackerel industry. From June to November each year, the eastern waters of South Korea become bustling with thousands of squid fishing vessels, supporting one of the country's most valuable fisheries and generating over $1 billion USD annually. Unlike species such as tuna or mackerel, which are typically harvested during the day, squid fishing takes place almost entirely at night. This is due to the squid's distinctive phototactic behavior. When a strong light appears in a dark environment, they quickly swim toward the source in search of prey. Taking advantage of this characteristic, modern squid fishing vessels measuring 30 to 60 meters in length are equipped with high-powered LED lighting systems, capable of illuminating vast areas of the sea spanning hundreds of meters. On each vessel, the automated squid jigging system, originally developed in the 1970s, has been significantly upgraded with modern technology. The setup includes hundreds of luminous artificial lures, continuously operated by machines that lower and retrieve them in steady, rhythmic motion. At the same time, fishermen use radar and sonar to precisely locate squid schools at depths ranging from 50 to 150 meters in cold waters. Once the squid have gathered near the surface, the automated jigging system immediately operates at full capacity. Within just a few hours, each vessel can haul in between 1 to 3 tons of squid, an impressive figure compared to traditional fishing methods. After being brought on board, the squid are sorted and cleaned immediately. For Korean fishermen, squid are not only a primary source of income, but also a gamble in the night sea, where every trip comes with high fuel costs, harsh weather, and intense competition from international fleets. After docking at ports such as Sokcho or Busan, the squid are quickly transported to processing plants to be turned into a wide variety of products. Notably, in South Korea, the live dancing squid dish, known as sanakshi, has become a unique culinary symbol, reflecting the country's strong preference for extremely fresh seafood, despite ongoing controversies surrounding it. Not only does seaweed contribute nearly 50% of the Earth's oxygen, it is also one of the most mineral-rich ocean foods on the planet. And when it comes to seaweed, people immediately think of South Korea, a country known for its vast offshore seaweed farms. In the world of Korean seaweed, the most prominent is gim, a thin layer of seaweed that nearly disappeared after 1949, until British biologist Kathleen Drew Baker decoded its hidden life cycle, enabling humans to cultivate it for the first time. From the laboratory to the open sea, thousands of stakes transform the water's surface into seaweed farms, stretching across thousands of hectares, laying the foundation for a global seaweed powerhouse. From around November, when sea temperatures drop below 12 degrees Celsius, the seaweed begins to grow rapidly, as if a biological switch has been turned on. Within just a few weeks, thin blades measuring 15 to 20 centimeters blanket long stretches of nets extending for kilometers. That is when the drum harvesters appear. Steel cylinders over 1 meter in diameter, operating like giant harvesting wheels on the ocean's surface. As vessels move along the net lines, rotating blades spin thousands of times per minute, carefully trimming only the upper portion of the seaweed, while leaving about 5 centimeters of the base intact so it can regrow for the next harvest. This allows a single stretch of net to yield multiple harvests in one season, a true form of rice farming on the ocean. Immediately after being cut, the seaweed is suctioned into a preliminary washing system on board, then mechanically pressed to remove excess water. Within minutes, fresh seaweed is compressed into netted bundles weighing up to 800 kilograms, ready to be transported ashore the same night. Korean seaweed is especially renowned for its superior quality and strict production standards. Cultivated in cold, nutrient-rich waters, it develops a deep color, natural sweetness, and a distinctive crisp texture. After harvesting, it is quickly processed and dried to preserve its flavor and nutritional value. This combination of ideal natural conditions and advanced processing techniques has made Korean seaweed one of the most sought-after products in the global market. Abalone, one of the 4 great delicacies of the sea, is not only a culinary symbol, but also a high-value pillar of South Korea's seafood industry. Each year, with just around 20,000 hectares of coastal aquaculture, the sector generates nearly $700 million USD, elevating the country's reputation on the global fine dining map. Abalone are first bred in high-tech hatcheries under strict environmental and water quality control standards. Once they reach a certain size, they are transferred to offshore cage systems for grow-out. Their primary diet consists of nutrient-rich natural seaweed. Combined with clean waters, stable temperatures, and a nutrient-rich ecosystem, South Korea offers ideal conditions for producing abalone with thick flesh, deep sweetness, and top-tier quality. The harvesting process for abalone here begins when culture trays are lifted from the sea using automated hoists. Each tray holds around 200 to 300 individuals, weighing dozens of kilograms. As soon as they leave the water, the abalone are quickly rinsed to remove algae and sediment, a fast but essential preparation step before the most critical stage of the entire process. What follows is a precise battle of skill that determines their commercial value. Workers use specialized tools to carefully insert along the shell's edge, detaching each abalone from its surface while preserving the foot, the single attachment muscle, yet also the most valuable part. This step demands exceptional tactile precision, as even slight misapplied force can tear the muscle, immediately downgrading the product's quality. On the premium seafood market, abalone from South Korea is ranked among the finest, second only to wild varieties from Japan. Prices can reach 80 to 120 USDs per kilogram for large live specimens, 2 to 3 times higher than mass-farmed abalone from China, where production is optimized at an industrial scale, but often lacks the firm texture, deep sweetness, and survival rate achieved through Korea's tightly controlled aquaculture systems. Whether a seasoned foodie or a first-time explorer of Korean cuisine, almost no one is unfamiliar with the allure of octopus, the true vedette of seafood in South Korea. Unlike squid, which are drawn to the surface by bright lights, octopus are masters of ambush on the seafloor. They do not chase, they wait. As a result, in places like Sokcho and Ulleungdo, fishermen do not pursue their catch, but instead lower artificial homes to the seabed, allowing the octopus to enter the trap on their own. The key lies in the bait: crabs, fish scraps, and offal, highly attractive food sources that can raise the capture rate to 70 to 80%. Once prepared, the traps are deployed in long lines, spaced about 10 to 15 meters apart, forming vast fields of traps across the seafloor. The most common designs are cylindrical cages made of plastic or metal with narrow openings, alongside ceramic pots or plastic tubes that mimic natural shelters. Beneath cold waters tens of meters deep, hundreds of these traps are linked into extended lines, each preloaded with bait. But the moment an octopus crawls inside, the one-way entrance transforms what seemed like a safe refuge into a trap with almost no way out. By dawn, when the sea is still veiled in a thin layer of mist, boats return to their trap lines. Each rope is slowly hauled up by hand or through small pulleys, lifting one pot after another from the water, growing heavier with every meter. If the timing is right, inside are octopuses weighing dozens of kilograms, but just a few hours too late, and an entire line can come up nearly empty. Unlike common octopus that weigh only a few kilograms, giant octopus require fishermen to use steel hooks and pulleys to bring them on board. While in Hokkaido, Japan, they can sometimes be controlled with specialized rods. In the East Sea of South Korea, these 30 to 50 kilograms creatures cling tightly and thrash violently, turning each haul into a real struggle between humans and a powerful deep-sea animal. From the deck, the freshly caught octopus are sent directly to coastal seafood markets and processing facilities, quickly making their way onto dining tables in the famous sanaki, where the tentacles still twitch gently on the plate, as if they have yet to realize that their journey at sea has come to an end.
Sort the large ones.
Did you know that every year, humans harvest tens of millions of tons of chili peppers to produce around 33 billion bottles of hot sauce? A flavor catalyst that can transform any dish? Just a few drops are enough to trigger an intense reaction in your brain, releasing endorphins and turning the sensation of heat into something strangely addictive, a feeling millions of people can't resist. The journey of every bottle of hot sauce begins in vast, sun-drenched fields where harsh heat nurtures each pepper, infusing it with intensity before it's harvested at peak ripeness and quickly transported to modern factories. Here, through the combination of human expertise and advanced technology, these small peppers undergo a complete transformation, crushed, blended, and refined into a smooth, vibrant red sauce, carrying a perfect balance of heat, acidity, and deep, irresistible flavor. Now, join Agriculture Insight on this journey, where tiny peppers quietly redefine the way the world experiences food. China is often called the world's chili factory, producing over 16 million tons each year. But when it comes to bottled hot sauce, the spotlight shifts to the United States, where heat is standardized, refined, and exported worldwide. Every year, Americans consume billions of bottles of hot sauce, fueling an industry worth over $3 billion. Through iconic foods like buffalo wings, burgers, and pizza, this bold flavor has spread to hundreds of countries across the globe. Did you know what the hottest chili in the world is? It's the Carolina Reaper, measuring over 2.2 million Scoville units. Just a tiny bite can trigger instant sweating, numb your tongue, and make your throat feel like it's on fire. Yet ironically, most popular hot sauces don't rely on extreme heat. They prioritize balance, preserving flavor over intensity. And that's where two distinct philosophies emerge. Tabasco, aged for years in wooden barrels, delivers a sharp, tangy kick, while Frank's Red Hot uses cayenne peppers to create a smoother, more consistent heat. That balance is exactly what makes Frank's the perfect companion for food, not overpowering it, but elevating it. So what about you? Do you prefer a sharp, intense kick, or a smooth heat that keeps you coming back for more? And now, let's head to California, where vast fields stretch beneath year-round sunlight, where warm temperatures and fertile soil quietly nurture cayenne peppers, the very ingredient behind the signature heat of famous sauces like Frank's. The process begins in shaded nurseries, with trays carefully filled and seeds placed into individual cells, covered with fine soil and kept consistently moist. After about 7 days, the first shoots emerge, but this is only the beginning. Farmers continue to monitor each tray, adjusting light and water and removing weaker seedlings early to ensure uniform growth. In the past, everything was done by hand. Farmers bent over row after row, digging small holes, placing each seedling carefully, covering it with soil and watering it. A full day of work could only cover a small area. It was slow, but precise. Today, many farms in California rely on specialized transplanting machines. These machines move steadily along the rows, automatically creating holes, placing seedlings, and covering them within seconds. A single machine can replace up to 50 manual workers, ensuring each plant is set at the right depth and spacing with remarkable consistency. Yet, whether by hand or by machine, the most important part remains unchanged: daily observation. The plants respond quickly to changes in soil moisture or weather. If not corrected in time, yields can drop by up to 30%. But when everything is managed well, each plant can produce nearly 2 kilograms of peppers, and the entire field gradually turns a vivid red, the clearest sign of a truly successful harvest. After about 5 months from planting, cayenne pepper plants in New Mexico begin their harvest season, typically from August to October, when entire fields turn a vivid shade of red. Harvesting is never random. Workers rely on color, skin firmness, and stem strength to determine whether each pepper meets the standard. Only those with a uniform red color, smooth skin, and no damage are selected, because even a single poor quality pepper can affect an entire batch of sauce. An interesting detail is that peppers don't ripen all at once, so each field must be harvested multiple times, spaced a few days apart. What seems like a simple task is actually far from easy. It requires both experience and a great deal of patience. Workers spend hours bent over under the sun, carefully selecting each pepper one by one, and before long the strain begins to build in their backs. In vast chili fields spanning hundreds of hectares, harvesting is no longer done by human labor alone. It is powered by massive, specialized machines. These harvesters move along the rows, using shaking and cutting mechanisms to separate ripe peppers from the plants, then carry them onto conveyor belts for on-site sorting. In just 1 hour, a single machine can pass through tens of thousands of plants and process up to 10 to 15 tons of peppers, a speed that would take an entire crew working for days to match. However, this efficiency comes at a cost. Precision. Machines cannot perfectly distinguish which peppers meet the highest quality standards, so mechanically harvested peppers must go through additional sorting systems afterward. For premium hot sauce production, the human touch still remains irreplaceable. After harvest, in many traditional production regions, chili peppers are not sent to factories right away, but are spread out under direct sunlight, beginning a slow yet decisive transformation. Billions of vibrant red peppers are laid across drying yards or large mesh racks, left to sun-dry for 3 to 7 days under temperatures that can exceed 35 degrees Celsius. But this is more than just drying. As moisture evaporates, the structure of the peppers changes. Compounds like capsaicin become more concentrated, while natural sugars are compressed, creating a deeper, richer heat with a lingering finish that fresh peppers simply cannot achieve. However, this process is also a gamble with nature. A sudden rain or a spike in humidity can ruin an entire batch. That's why, despite its unique flavor, this method is now mostly reserved for small-scale artisanal production, used by brands like Yellowbird Sauce and Queen Majesty Hot Sauce to craft sauces with truly distinctive character. In modern factories, chili peppers don't wait. Within 24 hours of harvest, they are sent straight into processing lines to preserve their freshness and natural flavor. Here, the peppers are washed in industrial systems using high-pressure water and rotating drums to completely remove dirt and debris. They then move along conveyor belts through sorting systems, where unripe, damaged, or substandard peppers are removed, ensuring that only the best quality peppers proceed to the next stages. This approach creates a completely different flavor profile compared to sun-dried chilies. Fresh peppers retain their moisture, delivering a bright, sharp heat that spreads quickly, while dried peppers, having lost up to 70 to 80% of their water content, produce a deeper, richer heat that lingers much longer. In modern factories, instead of being sun-dried, chili peppers are typically processed in industrial drying systems to ensure strict quality control. After being washed, the fresh peppers are transferred into drying chambers, where temperature and airflow are precisely regulated, usually maintained at around 50 to 70 degrees Celsius for several hours. After being cleaned, the peppers are fed into high-capacity grinding machines, typically hammer mills operating at speeds of up to 3,000 revolutions per minute. Within seconds, the cellular structure of the peppers is completely broken down, releasing capsaicin, natural red pigments, and aromatic compounds, forming a uniform slurry known as pepper mash, a thick mixture of pulp, juice, and seeds. The mash is then blended with salt at a ratio of about 3% and transferred into large fermentation tanks, where it undergoes a fermentation process lasting around 8 weeks, typically maintained at approximately 32 degrees Celsius, 90 degrees Fahrenheit. In this environment, Lactic acid bacteria, such as lactobacillus, convert the natural sugars in the peppers into lactic acid, creating a mild tang while naturally stabilizing and preserving the mixture. Throughout this process, the mash continuously releases carbon dioxide, CO2, and evolves day by day, almost like a living system in motion. What's remarkable is that the heat doesn't diminish, it simply changes in perception. Capsaicin remains intact, but as it interacts with acids and newly formed aromatic compounds, the heat becomes smoother, deeper, and more evenly distributed, rather than sharp and aggressive like fresh peppers. For sauces like Tabasco, fermentation doesn't take place in modern steel tanks, but in specially selected oak barrels that were previously used to age whiskey. After being ground and mixed with salt, the pepper mash is transferred into these large wooden barrels, sealed and topped with a layer of salt to prevent air from entering. Under these nearly airtight conditions, the mash is aged for up to 3 years, an exceptionally long period in the food industry. The barrels naturally breathe, allowing a tiny amount of oxygen to enter, just enough to sustain fermentation without spoiling the mixture. During this time, the mash doesn't just ferment, it matures, much like wine. The flavor becomes deeper, rounder, and less harsh with each passing year. As a result, Tabasco isn't just hot sauce, it's one of the few sauces that is truly aged like wine, where time itself is the most important ingredient, shaping its flavor. After the fermentation process is complete, the pepper mash is pumped into large industrial mixing tanks, each capable of holding up to 50,000 liters. Here, the mash is combined with vinegar and a carefully controlled blend of spices, following a precise, standardized formula. The mixture is then gently heated for about 3 minutes at a controlled temperature, just enough to stabilize microbial activity and activate its aroma, without actually cooking or damaging the natural flavor structure of the peppers. It is then transferred into continuous mixing tanks for around 4 weeks, where the vinegar gradually penetrates every part of the mash, breaking down its original structure and transforming it from a thick mass into a smooth, uniform liquid sauce. This stage is critical in creating the balance between heat, acidity, and aroma. If done too quickly, the sauce may separate. If left too long, the flavor can become flat and muted. Once the mixture reaches a stable state, it is passed through a multi-stage filtration system using ultra-fine meshes of around 0.5 to 1 millimeters, where all seeds and fibrous material are completely removed. This step defines the signature texture of industrial hot sauce: smooth, viscous, and perfectly uniform, with no graininess and no separation. The entire final processing stage, from mixing and heating to filtration, takes place in under 1 hour, yet it determines nearly the entire sensory experience of the product. From a raw, fermented mash, the system transforms it into a finished hot sauce, ready for bottling at speeds of up to 500 bottles per minute, a scale that would take weeks to achieve if done manually. After filtration is complete, the smooth and uniform hot sauce is pumped directly into an automated bottling line, one of the fastest and most precise stages in the entire factory. Pre-cleaned and sterilized glass bottles move continuously along conveyor belts, passing under filling nozzles calibrated to dispense exact volumes down to the milliliter. In a split second, each bottle is filled with remarkable precision, with only minimal deviation. Immediately after filling, the bottles move to an automated capping system, where plastic caps are tightened with consistent torque to ensure an airtight seal. A protective seal is then applied to preserve quality during transportation and storage. The process continues with labeling and final inspection, where each bottle is scanned to detect any issues in fill level, sealing, or appearance. Operating at speeds of up to 500 bottles per minute, this stage doesn't just complete the process, it transforms months of production into a finished product ready for the table in a matter of seconds.